Hello. So we are streaming right now successfully. Okay, beautiful. So let's launch our course detail. Okay, so this is where we were last time, and we want to develop a project which is a calculator, and we'll have to use functions with outputs. So we've seen functions with only an execution body, functions with inputs that allow for variation, and execution of the function body, and how we'll see the final form of functions that can have outputs. Pause 1. Create a function called format name that takes two inputs, fname and lname. So first name and last name, okay. Okay, so let's define format name. Okay, and it's gonna take first name and it's gonna take last name. Okay, use the title function to modify the fname parameters into title case. Okay, so we are going to take so fname is going to be equivalent to fname.title and last name to title. Okay, syntax: you can create a function with a body, input and output like this. So it's gonna be way better if we just returned the content, which is fname dot title, exactly, and return last name title as well. So this is not executed. We return only one thing, so maybe like this. Okay, so let me test this out. Let's print format name, and my first name is gonna be Mr. Last name is gonna be Robot. Okay, let's see. So yes, it's currently working as it's supposed to be. Easy. Print versus output. Return versus display. The return statement is used to give back a value from a function which can be used later, while print is used to display a value to the console only for the programmer to see. Okay, beautiful. So print is only for development period, but not for the production period. That's why we use return. Okay, it passes the value that has been returned to the print statement to prompt to us the output.
By the end of the lessons today, you'll have understood how functions really work, how you can use them to reduce redundant code, and how you can provide inputs to functions as well as providing outputs. Once you're ready, head over to the next lesson and let's get started. To begin, the first thing I want to talk about is more on functions. So we've already seen a couple of things that we can do with functions. The first thing I showed you was how to create a very simple bog standard function using the def, the name, the empty parentheses, and then the colon. And then within the body of the function, you can do a bunch of things which will be carried out.
Okay, so this is very simple. So we could use the return. So this is what's new.
We start off with a simple function, and in this case you'll notice that even though I could, I'm actually not giving it any inputs. The inputs and the outputs are completely separate from each other. So this is a normal function that you've seen many times now. And within the body of the function, I'm going to do some piece of calculation. Let's say I'm going to calculate what is 3 times 2 and then save it to a variable called result. Now, once that's done, I can use the output keyword, which is return, and then after that keyword, I can put whatever it is I want to be the output of this function. So in this case, the output is the result. And what that means
Okay, that's interesting.
is when I call this function later on and it runs, then it will go ahead and output this result, and it replaces this line of code where this function was called. Now, that result is held in the code where the function was called, and I could save it to another variable. Result, of course, equals 3 times 2, and that means this output now equals 6. So this is what the code might look like. Somewhere I would define my function which has an output, which you can tell by the return keyword.
Okay, that's correct.
Now, at some other point in my code, I decide to call that function. And once that function executes, that return, or whatever is outputted, replaces the function call. And at the very end, it means this variable output will store whatever
The value that has been returned from the return statements that has been defined inside the function.
the output is. So in this case, output would be equal to 6. The way that I like to think about functions with outputs is almost kind of like a machine, right? If you had a machine where in goes some empty bottles, and after some processing or some inputs, out comes a bottle filled with milk. So in this case, this function has an input, the empty glass bottle. It has an output, the glass bottle filled with milk. And in the middle, there's some processes or some code that's being executed to create this change. This ties together all the things that we've learned about functions.
So now head over to the starting file.
Okay, perfect. So we have done almost all of these ourselves. Let's give a string to total case in Python. Okay. And then we have the challenge which we have made. And then we pass the return statement. Okay, interesting. Rather than using a variable to just return it at the end, we could just go to here. Could just return it by itself, and there is no need to use f-string. If you are willing to use it, then hold on a second, it will be a little bit better. It's gonna be without any comma like this. It's gonna be more of a string. So we're gonna add these curly brackets like this. And for the last function, which is last name dot title, we're gonna add the curly bracket. Just like that, I could say Mr. Robot like this, like a string. And we're gonna have, rather than a tuplet like this, we're gonna have a little more text being outputted. So yeah.
And we're now within the function where we have access to these two inputs, fname and lname. Now the formatted fname becomes the title case version of the first name, and the same thing happens with the last name. So we now have a formatted fname and a formatted lname, and that is what's going to be returned as the output. Now, once that's completed, that output replaces whatever was in between the print statement, which is where we called this format name function, and this is what gets printed into the console. As I mentioned before, we've actually already been using functions that we didn't create that have all of these functions.
Yes, so the print function has an input. Okay, it could be a string, it could be a function that returns a string, it could be anything, maybe a list, maybe. And it has a set of processes that take the input and output it to the console that is, built into PyCharm, or you could use the bash console that is in Linux. So you could just use Python 3, and then we are inside a Python environment, and we could just say print okay, maybe print hello, and this will output to us hello. Okay, so this print statement takes this input, which is this string hello, and it goes through a set of processes and gets outputted into the console in this clean manner. Okay, the same goes with other types of data, boolean, integers, float, etc. Okay,
functionalities, right? For example, the len function takes an input and has an output. The input is going to be a string, my name again, seems to be really.
so here this function, which is the length, let me just play with it. Okay, so rather than print statements, I'll just leave it as print. Okay, Python 3. Okay, no problem. So we're gonna print first of all this, so that we could see it on the console. And we are going to use the length function, and we're gonna use, for example, the same string. Okay, we're gonna have number 5. So what this does is actually making a list. So let's make a list, and we're going to assign this list to this function. So it takes this function, for example. Okay, so hello like this, and then it for loops each character in the list. And for that reason, we are going to take this character, and when we find a character, we're gonna add a number, for example. This is not optimal. Let me just use this in PyCharm because it's so easy to edit. Comment out this. This is gonna be very easy to build your own len function. Okay, so let me paste this. Okay, intents my for loop. Okay, sorry. Okay, beautiful. Okay, so we're gonna use a length. It's gonna be 0, and then we're gonna count if we find out a character. Okay, so the length is gonna be +1. That easy. And for that reason, we are going to just print the length, and we're gonna see in this case 5. Okay, and we're gonna have the same output for the length function. So yeah, hello, beautiful. So let's run this code. So yeah, so we have here 5 and here 5. So the length function, which is a very simple function, is actually transforming this string into a list and iterating through each character. For example, H, E, L, L, O. And when we find a character that we have iterated through, we're gonna add 1. We're gonna add 1 to this variable, which is the length. As simple as that. So we could indent all of this code into our own function, and we're gonna call it define build length function. See, so this is length. Yes, exactly. Length function. So we are taking a text as input, and for that text we are going to list that text exactly, and yeah, that's it. That's it, as simple as that. Exactly. So let me just try this function. Okay, length hello, and we're gonna see another 5, a third 5, because we are going to, rather than using prints, we're just gonna use return length, simple as that. And we are going to print this. Sorry. Okay, we are going to just print this out. Beautiful. So let's see. Okay. Interesting. Maybe we need to add strings in here. Let's see what that does. Oh my god. So we are having an error. Interesting. Actually, we are passing a string to it. So what do we have an error? For which reason? Let me ask AI real quick, because that seems to be weird. I'm gonna use the light version. Say, why do I have here an error? Okay, the code snippet you provided, while functional for what it does, it's not inherently an error in Python syntax. However, there are a few significant shadowing the built-in. Okay. Okay, so maybe we need to change the name of this variable. So maybe listed text. And then I'm gonna use this list text in here. Okay, we're still having the same error. Type of list object is not callable. That's interesting. For some reason we cannot use the list function that is built in. Why? Should I build my own list function or what? It's gonna take much more time, but it's gonna use the same concept, which is what you call it, a for loop, and then we're gonna append all of those characters to an empty list. Should I build it? Okay, let's build it. No problem. So I'm going to comment out all of this, and we're gonna build our own list function, because this one is not working as it's supposed to be. For that reason, we're gonna use our own. Okay, so we're gonna lead an empty list. It's gonna be equivalent to an empty list. Then we're gonna need a text variable, and we're gonna assign to this text a string. It's gonna be hello. Then I'm gonna use this for loop to iterate through the text. So for each character in text, yes, I'm gonna append this character to the empty list exactly. And let me just print the empty list, and we're gonna have H, then a comma, E, comma, L, a comma, etc. Exactly. So this is our own built-in list function. I'm gonna append this. I'm gonna define my own function. I'm gonna call it lists. I'm gonna call it my list function. Okay. I'm gonna add a column. Beautiful. Okay, so after I define this, hold on a second. So after I define this, I cannot even delete it. What? What's happening? Okay, that's weird. Okay, let's delete it. Copy it and delete. For some reason I cannot delete it. What? Is this an error? Oh, the keyboard is off for some reason. What's wrong with the keyboard? Are the batteries out or what? I don't get it. Okay, it's working again. Beautiful. So I'm gonna copy this and delete it. And I'm gonna go and paste it in here. I'm going to comment out my built-in function, which is the length function, and I'm gonna use my list. This is gonna take text. Okay. And this text is gonna be inputted. So perfect. Okay, I'm gonna need to return the empty list. Yeah, exactly. So after I've made these changes, I'm gonna use my built-in mylist function. Exactly. And this should work. Exactly. So let's see. Okay, so it's working. So we have printed the length and it's working. So that's why you should be capable to build your own functions if the system functions were not actually working. Like this example. Okay, this time it works like magic. But back then it didn't work. And for that reason we have built our own list function, okay? So if you have this skill to build your own tools and not be dependent on the built-in tools, then you could actually go further on compared to other developers, okay? So build your own tools if the built-in tools were not doing their job, okay?
Really obsessed with my own name. So now this line of code is going to run this built-in length function, calculating the number of letters inside this input that we've given it, and then it's going to return the result as an output, which we can now capture inside a variable. This is the input, this is the function, and once this is completed, the return, or whatever it is after the return statement, is going to replace this part of the code. Then that result or output then gets stored inside this variable. So this return keyword is really the most important thing in order to create a function that has an output, because everything that comes after it is going to replace where the function was called.
Now, students often ask me, well, what is the difference then between...
Okay, that's interesting. So it's the same as I have explained. So yeah. Okay, beautiful. Okay, interesting. Okay, so we could actually skip this because we have digested everything. Let's go to the next video and see.
In the last lesson, we looked at functions that return some sort of value. We created a function called formatName that returned a string. In this lesson, let's see what happens when a function has more than one return statement. When the computer encounters a line that has the word return on it, then it knows that this line is the end of the function. If I add a line of code after the return keyword, notice what happens when I run this code. It doesn't ever get executed. And this is because the return tells the computer that this is the end
of the function, exactly.
Of the function, and you should now exit the function.
So whatever you have appended after the return, it's not going to get executed, okay? Because this is the final output.
Actually have multiple return keywords within the same function, And you can even have a empty return keyword. So just the return keyword without anything afterwards. So for example, we could check whether if the f name is equal to an empty string or the L name is equal to an empty string. So in this case, it means that when we called format name, maybe we didn't give it any inputs. For example, let's say that instead of just calling the function as it is, we actually use...
Okay, that's interesting. Let me just see how this is gonna be like. So I'm gonna comment out all of this. And I'm gonna remove the comments from here. And from here as well. Beautiful. I'm gonna need some space. Okay. So here we're gonna actually give it nothing, just empty strings. Okay, see how that's gonna go. Okay, beautiful. So it prompts me robots like this. Interesting. So let me catch this case if name, sorry, but I've chosen if name was equivalent to an empty string, or if the last name was equivalent to an empty string, we are going to return nothing. Let's see. None. We get a none. What about returning an empty string? Okay, an empty string gives you nothing. It doesn't give you even none. But we could make it ourselves. Okay.
used the input function. So what is your first name and
input function. This is a very built-in function that is very hard to build on your own. Ask AI if that was possible to build your own input function. Is it possible to build your own input function in Python? Let's see. Yes, it's absolutely possible to build your own function that behaves like Python built-in input function, one that performs similar tasks like getting user input from the console or another source. You cannot completely replace or override the behavior of the built-in input function itself for the rest of the running program without using advanced, often discouraged techniques like monkey patching the built-in module. Interesting. But you can certainly create a new function with a similar purpose. Creating a custom input function is a simple example of a custom function that prompts the user to capture their inputs and includes built-in validation to ensure. So we are using built-in validation in Python to ensure they enter a non-empty string. To define my custom input, we're gonna use this input, which is prompt. It's gonna be equivalent to this text exactly. So custom function to get input from the user, ensuring the input is not empty. So while true, so we're gonna use a while loop, and okay, use the built-in input function internally to read the data. Is he stupid? Look at this. He used input function to define his own custom input. Like, this is stupid. You should, come on. You should not use input built-in function at all. You should build it from scratch. Okay. From scratch. Okay, beautiful. And then we're gonna add, so we're gonna enter this. Okay, that's a fascinating, challenging request. The short answer is you absolutely cannot create a function that reads either input from the standard console entirely from scratch in pure standard Python. It's a detailed explanation of why and what the closest you can get involves. Why it's impossible in pure Python. So the core functionality of reading keystrokes from the keyboard, handling the enter key press, and displaying characters on the screen, the terminal console is handled by the operating system and relies on low-level system calls, usually involving C libraries, like those in the standard C library, often linked via the OS kernel. Okay, so Python built-in input function is essentially a convenience wrapper around those low-level OS-specific mechanisms. It relies on Python's standard library modules, sys and OS, that are already integrated with the underlying C implementation of Python. The closest you can get using external libraries or OS interaction to bypass the built-in function and interact more directly with the terminal. You must use a library that provides this lower-level access. This is not from scratch in the sense of not using any pre-written code, but it's a step closer than just calling input. So we're gonna use sys.stdn read line. So we're gonna use this function from this module, which is the sys module. So the least built-in standard way. Okay. This uses the standard input string directly, which is what input uses internally, but it requires manual handling of the trailing new line character. Okay, so we're going to define this function, and we're going to use this input, which is the prompt. So we're going to print the prompt to standard output. So we're going to use this module. Okay, so using this system module that could interact with the low-level machine, we could actually write this input, which is the prompt. And crucially, we must flush std out to ensure the prompt appears immediately. And then we're gonna flush it. Interesting. Okay, this is an interesting module. Read the entire line from the standard input, and then we're gonna read it. Okay, so we're gonna execute. Okay, so we're gonna execute this function that is built in this module to read the line. We're gonna strip the trailing new line character. That read line includes return. Okay, we're gonna return this new line. Okay, interesting. Use the data my scratch input read line. Okay, print received user data. Okay, let's try this and see if it's work, if it give us an output in here in the console. Okay, we're gonna comment out all of this. I'm gonna paste this and see if we got this. Maybe enter a secret. It's gonna be I love low machine learning. Okay, and yes, that did work. That's scary. That's exactly scary. Okay, so like this, we have made our own function, which is input function. That's interesting. Okay, that's very interesting. Okay, that's kind of scary though, and interesting at the same time. Okay, beautiful. Limitation: this relies on the OS and the underlying C implementation, with actual keystroke buffering and reading, which is exactly what the built-in input does. It just skips the convenience features of input like automatic prompt display, flushing in some environments. Using OS-specific libraries for true keystroke control to get true character by character input without. Okay. So rather than so getting a live keystroke, for example, in the console, like this, input. Okay, make a string. Ask the user about something. Exactly. So to get a live editing of the line in the console, which is what the input function does, we're gonna need to do this. Okay, to get true character by character input without waiting for enter, or to hide inputs like for passwords, you need libraries that talk directly to the terminal driver. From Linux, you would need to use libraries that deal with the Termios module to change the terminal mode from canonical, like line buffers, to raw, character by character. Okay, that's interesting. So we're gonna define this function called getRaw. Get a single character without waiting for enter. Okay. So we'll define this fg. Okay, that's a little bit advanced for me. Let me copy it and see what's gonna happen. Okay, interesting. Okay, so we have defined all of this. Okay. Interesting. So we are using this function, getRaw. Let's see. Let me print this thing, which is the prompt. Key. Hi, maybe. Let's execute this. Then we have an error. Okay, I'm not gonna get into this rabbit hole. Doesn't seem to be worth it. Okay. Let's continue the course.
What is your last name? Now what happens is it'll ask us for a input, and it will take these two inputs and then call that function and return the formatted version to be printed.
Might be curious enough to just check if there is somebody that tried to build his own input function. How to build your own input function in Python. Yeah, Python built-in functions and user input functions in Python are easy. Python user inputs. Okay, how to use input function in Python. Okay, your own custom. So nobody talks about that. It seems like a new idea. Nobody thought of. Let me use Google real quick. And Python. See if there's somebody in Reddit. Ask about that. Help. Function that uses input data. Custom input validation Python inputs with Python. We can create a menu with the input menu function. Python custom function. Okay. So nobody thought about this before. Okay, interesting. That seems to be interesting, isn't it?
So now in this case, it's possible that we might have just not given it a first name or not given it a last name, and it probably shouldn't go through these lines of code. But at the moment, it's still running this function, trying to get the title case from the empty string and then printing it. And I can prove this to you by just adding an extra word in here. So again, empty first name, empty last name, and then it's prints result, and then of course nothing. How can we get it to bypass the rest of the code if the user typed in an empty first name or last name? Well, we could use what I mentioned before, an early return. So we could just write return without anything afterwards, and this is going to escape the function. So it's basically going to terminate the function early. Now, this time, if I leave an empty first name and last name, you'll see it prints none, because there is no output from this to print. Now,
Yeah,
of course,
that's true.
it's probably safer to actually return something that tells the developer what's actually going on, so we can give a meaningful message like return something like this. So this way we can catch the cases when some
Okay, so before this idea, which is a very cool idea, goes out of my brain, I'm just gonna go and store it. And I'm gonna add it here. I'm gonna need new page. I'm gonna call them cool ideas. I'm gonna need bullets. Okay. Why not build your own built-in? Okay, built-in function like input or print Python. Using low machine libraries like C. Okay, like C modules, which means sys, OS, etc. Okay, this is a very interesting idea that nobody in the whole internet cared about, which means it's gonna be very interesting to the nerds that are developers, etc. So if this happened to be a video on my channel, then it's gonna be a cool video. I'm excited to work on it. So yeah, that's it.
something is not quite right, and then exit our function instead of wasting time for it to continue working on something that we don't want it to do. We've covered a number of things in today's lesson, and I want you to combine this with your existing knowledge to tackle the challenge in the next lesson, to get to grips with this concept of functions with inputs and with outputs.
Okay, so let's go. So I have a coding exercise that we have passed. So I'm gonna just delete everything before I cheat. So we have here leap year. It's a difficult challenge. Write a program that returns true or false whether a given year is a leap year. So a normal year has this amount of days. Leap year have this amount of days with an extra day in February. Okay, the reason why we have leap years is really fascinating. So in this video, we're gonna see that. Okay, so we're gonna learn about leap years.
A calendar year is made of 365 days, a number that refuses to be divided nicely, which is why we end up
Okay, yes, that's true, because it is an odd number.
with uneven months of either 30 or 31 days, except for February, the runt of the litter, which gets only 28, except when it gets
Okay,
29, and then the year is 366 days long. Why does that happen? What kind of crazy universe do we live in where some years are longer than others? To answer this, we
yeah, that's crazy.
need to know just what is a year. Way oversimplifying it, a year is the time it takes the Earth to make one trip around the Sun. This happens to line up with the cycle of the seasons. Now, drawing a little diagram like this showing the Earth jauntily going around the Sun is easy to do, but accurate
Okay,
Clearly, tracking a year is tricky when you're on Earth because the universe doesn't provide an overhead map. On Earth, you only get to see the seasons change, and the obvious way to keep track of their comings and goings is to count the days passing, which gives you a 365-day calendar. But as soon as you start to use
Okay.
that calendar, it slowly gets out of sync with the seasons, and with each passing year, the gap gets bigger and bigger and bigger. In
So our way to calculate years is not optimal. Simple as that. Okay, so this is how you work out whether if a particular year is a leap year. And every year that is divisible by 4 with no remainder. Okay. Except every year that is evenly divisible by 100. Okay. This is how we got it. If particular is a leap year. And every year that is divisible by 4 with no remainder. Except every year that is evenly divisible by 100 with no remainder, unless the year is also divisible by 400 with no remainder. So we have defined this function, define leap year. Okay, so this is a lot of math. So if it was divisible without any remainder, so we're gonna use the modulo sign and year divisible by 100 and except every year that is evenly divisible by 100 with no remainder. Okay, interesting. If year is divisible by 4 and year is divisible by hundreds with a 0 remainder, and year is divisible by 400 with a remainder. Okay, with no remainder, which is 0, 0. Exactly. Then return true, then return true. Otherwise, we're gonna return false. Okay, interesting. So this is just a piece of math that you have to translate. Simple as that. So it's a pretty silly
Hey
exercise.
guys, I want to quickly spend a few minutes talking about a concept in Python known as docstrings. Docstrings are basically a way for us to create little bits of documentation as we're coding along in our functions or in our other blocks of code. Now, previously we've seen that when we use other functions, like the ones that were already defined by Python, like the length function, I can see this little piece of documentation that tells me what this function is actually going to do, namely return the number of items in a container. So how can we create the same kind of documentation for the functions that we write? Well, we would do that using docstrings. The docstring has to go as the first line after the declaration. So here we've defined the name of our function, the inputs, and then after the colon, the first indented line will be the docstring. But that's not it. You also have to use 3 of these quotation marks, and it's in between these 3 quotation marks that you can write your documentation. We
Interesting.
could write something like, well, what is this format name function going to do? What would we want our future selves or another user who's using this function to know about it? Well, it's going to take a first and last name and format it. Notice how with docstrings, you can actually write strings that are multi-line. Normally, if I was to create a normal string, let's say, I don't know, A equals a string. If I hit the enter key, I'm going to get a warning because it's going to interpret this as the end of this line. And it won't see this closing quotation mark as being a part of this string. But when we use a docstring, we can write as many lines as we want, and it will be interpreted all as the same thing altogether, as if it was fitted onto the same line like this.
Yeah, true.
Now that we've added our docstring, it's time to see what it looks like. Now, if I call this function, you can see that the text we wrote here now gets populated in the documentation. It takes the first and last name and formats it to return the title case version of the name. So this is a way for you to be able to start documenting your functions and giving each function a little bit of an explain.
Yeah, that's true.
Now, you can also use this as a multi-line comment. So notice how when we write a comment and we go to the next line, it becomes code again. Now, you can, in fact, use something like this, where you just comment as many lines as you like, and this will be interpreted as a comment as long as it's not assigned to anything. So for example, if I created a variable, then this is now a piece of code. Because it's a little bit confusing, the official Python guidance is actually to avoid multi-line comments like this. What is actually much easier is to just write your multi-line comment and then to highlight all of it, and then to hit Command and / or Control / on Windows.
Okay,
That's
true.
a much better way of differentiating the comment from actual pieces of code. Have a go at adding doc strings to the other functions that you've created and see it show up when you call your functions.
Okay, interesting. Okay, so we have this quiz that we are going to retry. So we're gonna start the quiz. Okay, so without running the code below, what do you think will be printed in the console? So we are going to define, so this, we're gonna use the add, and we're gonna add 2, okay. Okay, so 2 to this multiplication, okay, and we're gonna multiply this with this division. So we're gonna use this, so we're gonna divide 8 and 4 is gonna be 2, and here's gonna be 10, and it's gonna be 12. Okay, that's easy. Let's check that, pretty easy. Okay, define outer function A and B, define inner function C and D, and then we're gonna return C plus D. Interesting. And then we're gonna return inner function A and B, and then we're gonna assign that to the result, which is 5 and 10. Actually, we're gonna return 5 and 10 again. We're not gonna calculate it because we are not doing anything with it. Maybe this or a syntax error, one of the two. Okay, so which means a syntax error. Oh my god, I was wrong. So it's gonna be 15. Yeah, that's weird. A equals 5, which means C equals 5. B equals 10, which means D equals 10. Output of inner function becomes the output. Oh, I didn't know that. I didn't know it exactly. It was new information for me. So what will be printed in the console after running the following code? So we're going to define my function A. So if A is below 40, we're going to return that and print terrible. We're going to return nothing actually. And this is not going to be returned. Okay. So what do we use here? We are using 25, which is below 40. So we're going to have none. Okay. Exactly. Okay, so we're going to continue.
So we're now ready to tackle our final project of the day, and that's building.
Okay, so this is very easy project. So we're gonna ask about the name. Okay, Mr. Rala. Not this one. So this one we have built before. There's no need to rebuild it. Okay, let's see. It's here actually. Yes. Okay, so this is the project. So it's the first number. It's gonna be 1. We're gonna choose the plus sign. It's gonna be another one. Then we're gonna input this, and then we're gonna have a while loop. It's very easy. Okay, so for this case, I'm just gonna go and go to the last, which is in here. The goal is to build a calculation program. Just in storing functions as a variable value, you can store a reference to a function as a value to a variable. Okay, my favorite calculation equals add. My favorite calculation. Okay. Oh, that's interesting. Will return 8. Oh, yeah. In the starting file, you'll see a dictionary that references each of the mathematical calculations. Okay. That's interesting. That can be performed by our calculator. Try it out and see if you can get it to perform addition, subtraction, multiplication, and division. First, pause to do. Write out the other 3 functions. Subtract, multiply, and divide. This is very easy. She made it way easier as well. So I'm gonna just let the integrated AI do it. It's so much simple. Okay, so this is the multi, and this one's subtraction. So we need to define the division exactly. Yeah, simple as that. Okay, so I'm gonna just make a while loop. So while true. I'm not gonna try. I'm gonna go and take this repeats equivalent to input. Do you want to subtract? Do you want to repeat yes or no exactly? And if repeat is no, then we are going to break. And then this is the while loop that we are going to build our code at. So I'm gonna ask about operation, and I'm gonna ask about this. Pick an operation like this. I'm gonna copy all of that. Oh, sorry. I'm gonna copy all of this. Go to PyCharm. And I'm gonna use this technique. Exactly, and paste all of that. Okay. Okay, so this doesn't look as it's supposed to be for me. Just make it a little bit more elegant. Okay. Beautiful. So like that, it's more elegant to look at. Okay. And I'm gonna ask about the first number. So number 1. Okay, I'm gonna use a float. No problem with that. To be more precise, number 2 as well. Okay, so what's the first number? The operation. And what's the next number? Okay. Okay, beautiful. So I'm gonna use this order of asking the inputs from the user. Okay, so we have our variables that we're gonna use, and I'm gonna use this if statement. If this, then I'm gonna use the add function exactly, and then I'm gonna use an elif statements of subtraction. I'm gonna use the sub, another elif, and I'm gonna use the multi, and then I'm gonna use an else, and it's gonna be the division. Simple as that. Okay. And this simple program is done. So to do, write out the 3 other functions. To do these 4 functions into a dictionary with the values keys. Okay, we could add these functions to a dictionary. That's pretty interesting. Let's do that. I'm gonna call these operators. Operators, and it's gonna be assigned to a dictionary. Exactly all of this. Add, sub, multi, and division as well. Okay, sorry, I'm just gonna go like this. So there isn't comma in here. I'm gonna add a string. Yes, all of this. I'm not gonna add a modulo because it's not required. Okay, beautiful. Beautiful. Okay, so rather than using this add, I'm just gonna go and call the operators. Yeah. Operators, and the key is gonna be the plus sign. The plus sign, exactly. That's it. And I'm gonna go and add the numbers exactly like this, number 1 and number 2. So I'm passing what you call that, the input, which is number 1 and number 2, to this function that has been assigned to the dictionary that has been defined in here, that returns this simple operation. So I'm going to use the same syntax pretty much in here. Okay, no problem. Rather than this, I'm gonna use this one like this. Beautiful. And for here, I could use this sign. Okay. And for the else statements, I'm gonna use this. It's gonna be the division. Beautiful. Beautiful. Okay. Okay, so this should function. So let's see. What's your first number? It's gonna be 1. Okay, that's interesting. Okay, not all of this. Sorry. Okay, like this. Let me rerun all of this. What's your first number is 1. Pick an operation. Okay, it's gonna be. What if I make it like this? It's gonna be way better. Yeah, exactly. Let me write it again. Okay, pick an operation. It's gonna be the plus sign. Second number is 1. Okay, I didn't return that, by the way. I should print that out. Okay, I could do that. Could I use the return in here? No, that would be stupid. That will not function. Okay. Okay, so I'm gonna just add the return statement for each case. So rather than repeating the codes, I'm just gonna go and assign this to results. Okay, so I'm gonna use this variable over here, over here. And if we finish this, I'm just gonna go and print the result, as simple as that. Yeah. Let's rerun this, stop and rerun, first number is 1. It's gonna be the plus sign, number 1, so we have number 2, exactly. And we finish, exactly, so that's very simple. So it functions as butter, and it's a very easy project. Okay, functionality, program asks the user to type the first number. Okay, add the logo from the art.py. Okay, let me add it. Let me add it in the while loop. It's gonna be way fun like that. I'm gonna import art. Okay, and I'm going to print art, exactly. Let's see. Okay, let me check the files. So we have the art.py. Oh, okay, so we're gonna print the logo actually. So let's just access the main again. So art.logo. Yeah. Let's rerun this again. Okay, beautiful. Here's the logo. So I just add number 1. The operation is gonna be minus. So the number is 1. Okay, it's gonna be a 0. Yes, I want to repeat. And then the logo is gonna be repeating for each time. Okay. This is very simple. Calculators are the easiest to develop. Okay, because Python is very good. It has all of these built-in functions for you. Okay.
Hey, well done. You've completed day 10. That's a lot of progress. Now, tomorrow is a big day because there's the capstone project coming up, your very first one. And before that, you really need to get a good night's sleep so that your brain is refreshed and you're ready to go.
Yeah.
So here are some of my tips for getting a good night's sleep. Firstly, don't set a wake alarm, set a sleep alarm as well. Have an alarm that tells you when it's time to start winding down, because we all know how easy it is to just keep watching YouTube video after YouTube video. I do that myself. Now, another really good idea is to avoid looking at a lot of screens about an hour or 2 hours before you go to sleep. The amount of blue light from the screens, even if you have night shift on, can make it really hard for your brain to start winding down and want to go to sleep. So one of the things I do is I actually have this, I don't even know what this is normally used for, but it provides a filter that gets rid of all blue light, and I sort of just walk around like this at night. So you can try this, or you can basically just read a book instead of looking silly like I am. And the important thing, but make sure
Okay, she looks silly with those glasses.
that you get enough sleep and you get good quality sleep, and that you're prepared and ready to tackle the next day. So have a good night's sleep. Good night from me, and I'll see you tomorrow.
Okay. Day 11.
Hey, it's Angela here. Congratulations.
So this is the first project I have uploaded to my channel. If you went to YouTube, it's the first project, and I have uploaded it like in German. I've made some editing, some stuff, so
Oh my god, meine Punktzahl war 11, der Computer ist 0.
okay, so I've made this in German, and I made a lot of editing, a lot of explanations, etc. And it was inspired from this day 11. Okay, and that was fun actually. I was using this chart, so the project wasn't that easy. So you had to make a chart to just keep track of the steps and how the functions should work. Okay, so yeah. And that's the first project I made, and it was 8 months ago. And since then, I didn't care anymore about coding, and I just gave up. So yeah, that's it. So after day 11, it's a new ground for me. We're not gonna go to intermediate. So to actually revenge my laziness, we're doing this challenge, and we are going to get to this intermediate phase and see how far we're gonna go.
I'm making it through the first 10 days. Today, I've got something very special lined up for you. Our first capstone project. Today, we'll challenge you to apply everything you've learned so far into one big project. You're going to need to dig deep and apply all your Python skills for this capstone project. But by the end of the day, you'll have built an awesome blackjack game to enjoy. This is probably going to be one of the hardest things you'll build yet, but at the same time, the end result is also going to be the most fun. The final project you're going to be building is blackjack. And
Okay, that's interesting.
if you head over to 247blackjack.com or search for any other free online blackjack game, you can hit play and you can click deal for the dealer to give you some cards. The game is really simple. Essentially, you're trying to get as close to 21 as possible. And all of the cards which have a jack, a queen, or a king count as 10. So you're adding these two cards up. 5 plus 10 equals 15, and you're trying to figure out if you can risk getting another card. So I'm going to click hit, and I'm going to get one other card, but that takes me over 21, and so the dealer wins. So this is the game that we're trying to create. This is what your version of blackjack is going to look like. Now, the user interface is a little bit simpler, but it's just as fun to play with. So our first two cards are a 9 and a 10. And it also shows us one of the computer's cards. Now, I'm already on 19, 10 plus 9. I'm close to going over 21, so I'm going to type N and end the game right there. I end on 19, the computer ends on 18, and because 19 is greater than 18, that means I win. Have a go at playing the final game, but once you're ready, head over to the next lesson so that we can actually build this game ourselves. For all of that and more, I'll see you on the next lesson.
Okay, let's go to the next lesson and learn more about this game, which is blackjack.
Alright, let's talk about the mechanics and the program requirements for the blackjack game that you'll create. For those of you who are not familiar with the game of blackjack, also known as 21, I'm just going to spend a few minutes to go through the rules with you. Blackjack is a game that's played using cards. And the goal of the game is to add up your cards to the largest number without going over 21. If the cards in your hand add up to more than 21, then it's called a bust, and it means that you lose immediately. And it doesn't matter how much you've gone over 21, as long as it's over 21, then you lose. Now, the way that the cards are counted is that...
Okay, so if the sum of these cards that you have in your hand go above 21, it means losing, straightforward.
that all the cards from 2 to 10 count as their face value. So a 6 is a 6, a 9 is a 9, etc. But the jack, queen, and king each count as 10. And the other special card is the ace. Now the ace can either count as a 1 towards your total, or it can count as an 11. And depending on whether if you've gone over 21...
Okay, that's interesting. Let me just repeat this really quick.
6, a 9 is a 9, etc. But the jack, queen, and king each count as 10. And the other special
So the jack and queen king, they have the score, which is 10.
card is the ace. Now the ace can either count as a 1
Or
towards your total,
11.
or it can count as an 11. And depending on whether if you've gone over 21 or whether if you're under 21, you can decide which value you want your ace to represent. Let's play a sample game. Let's say that the dealer over here got a 10 to begin with, and you got a queen, which also counts as a 10 to begin with. So these are the first cards that are dealt, and both of these cards are revealed. And then the dealer deals another card to each of you. Now the dealer's second hand is concealed, so you can't work out what their total is.
So you don't see the second card. That's true. So here we have a value of 13. And if he had an ace, it could be 11, which means 21. Or it could be 1 of value, which is 11. So in this case, we're going to see what's going to happen.
But you can see your own card. So at the moment, we don't know what the dealer has. It might be 10 plus anything. But we know that our score is 13, 10 plus 3. At this point, you might ask the dealer for another card. So now you have 3 cards, and luckily,
Okay, so now you have 20. Okay.
it adds up to 20 without going over 21. But there is also a possibility that you might have gotten a card that would have pushed your total over 21,
Which is 23.
which point you now lose. And it doesn't matter what the dealer has in their hand, you've already lost because you've gone over 21. Now let's say that we
That's
got
true.
lucky and our total adds up to 20. Now at this point, we say we don't want any more cards, and the dealer reveals their hand. If, like in this case, they end up with 20 and we have 20,
So it is a tie.
then we end up in a draw. So whenever your score equals the dealer's score, then you will draw rather than win or lose. Now, if on the other hand, the dealer ended up with an ace, which we know can count
It's going to be 10 plus 11, which is 21. Which means
as
he,
an 11, and they actually scored higher than us,
which is
they have
21.
21 and we have 20, well in this case,
Which means he wins and we lose.
we would lose.
Yeah.
Now, the rules also state that if the dealer ends up with a hand that's smaller than 17, so 16 or under, then they must take another card. Those are the basic rules of blackjack, but I reckon another card.
So if the score of your cards was less than 17, then you have to take another card, okay? And if your score was above 17, then you could choose to take another card or not, okay?
Those are the basic rules of blackjack. But I recommend that before you get started, head over to the link that's in the blackjack starting file and have a few.
Okay, not a problem. Let's check that link. Okay, so we go to the blackjack project. Interesting. So here's a bunch of links. Okay. Okay, where's that link at? It is at hint number 1. Okay. Let's go. Okay, so let's play the game. Blackjack. Oh my god, that's loud. That is indeed loud. Hold on a second. That is crazy loud. Oh my god. Okay. So my voice, can we just reduce the sound of this? Beautiful. Okay, so let's deal. So this might be this might get us some what you call it, copyright music. It's gonna be problematic. Okay, we don't want that. Okay, so we have those are our cards. Okay, so we have in here 5, And this guy has 5 in another card, which means we will need to hit. So right now we have 3 cards, which means we have here 12. And this guy, we don't know how much, so we need to hit more. Right now we have 18. Okay, so let's stand and see. Yes, 25, which means he loses and we win. Okay, interesting. Okay, let's deal again. So we have 6 in total. This player has 9. Another card. So we will need to hit. Okay, so we have 16. Let's hit again. 22, so we lose. Okay. So we didn't have enough luck. Let's deal again. So we have here 8. Let's deal. We have 18. 18 is not enough for me. Let's add. Okay. Choose hits while experts would recommend choosing stand. Click advice to see. Okay, continue. Okay, let's stand. Okay. I should have hit. That was a bad advice. The hit is to actually grab a new card. So here we have 16. Let's hit 24, which means we lose. So we are busted. We don't have enough luck. Let's deal. Let's hit. Okay, we have 21, which means we win. Beautiful. Beautiful, beautiful. Let's deal again. Let's hit. We have 19. Let's stand. He has 20, so he wins. Good for him. Okay, so this is the last time we're gonna play. We have 16. Let's hit. Okay, so we lose. We get ourselves busted. Okay, we have 10. Let's hit. We have 18. Let's hit again. We lose. Okay. So we don't have enough luck in this case. He has so much greater luck than us. Let's hit. Okay, so this is the last time I'm gonna play. You get split. What do you mean by that? Interesting. Here we have 16. Let's stand with that. Let's hit. Okay, let's stand with that and see. Yes, 20. Okay, that's weird. Okay, that's enough.
Started. Head over to the link that's in the Blackjack starting file and have a few games of Blackjack, just so that you can see for yourself how it actually works and how you win and how you lose. And then head over to the final version of the completed project and play our simplified.
Okay, so let's see the project of Python. See, do you want to play a game of blackjack? Type yes or no. Yes. Records 10, 5. Current score, which is 15. Computer's first card is 7. Okay, type Y to get another card. Yes, I want to get another card. So your cards are 10, 5, and 2. So current score is 17. Computer first card is 7, which is the only thing that we're gonna know. Yes, I want to grab another card. So my final score is 23, which means I'm busted and I lose. So let's play another game. Okay, type Y to get another card. Yeah. Which is 27. Okay, that was stupid. Let's play another game. My current score is 17. Now I'm gonna pass. And opponent went over. So yeah. So he's busted because he went over 21. Let's play again. Current score is 12. Okay, I need another card. And my current score is 22, which means I'm busted. Beautiful. So the game is very simple. Okay. Okay, so let's build it. I think this is enough hints. So this is the cards this is the list that we're gonna work with. We have the kings, the queens, and the jack, which has this value 10, 10, 10. Then we have the ace, which is 11. Okay. Then we have 2, 3, 4, 5, 6, and 8, etc. Okay, interesting. Interesting. The deck is unlimited in size. There are no jokers. Jack, queen, king all count as 10. The ace can count as 11 or 1. Use the following list as a deck of cards. The cards in the list have equal probability of being drawn. Cards are not removed from the deck as they are drawn. The computer is the dealer. Okay, interesting. Interesting, so let's build this from scratch. So we're gonna need to use the module. Okay, imports random. Beautiful. So we're gonna need a while loop. While true, okay. And I'm gonna need to do this repeat. And I'm gonna ask about input. Do you want to play? Do you want to continue? Exactly. You want to continue. If the answer was no, then we are going to break. Exactly. Okay, so this is the main while loop that we are gonna work with. So we are going to define some functions. The first function, which is it's gonna be okay. Let's see which function are we gonna do. There is a very interesting rule in here, which is the ace. So I'm gonna define a new function. It's gonna be called ace cards, and it takes the inputs as a card. Okay, beautiful. And if card was equivalent to 11, so if we drawn this card, which is 11, so if the total score, so if the score was equivalent, so I'm gonna add here a score as well as an input. So if the score was equivalent to if it was below 70, like this, 17, then we're gonna return this value, which is gonna be 1. Okay. Okay, else we are going to return the value of it, which is 11. Okay, that's beautiful. That's beautiful. Beautiful. Okay, so this is the ace card function that we have to develop. The deck is unlimited. Beautiful. There are no jokers. The queen count as 10. The ace can count as 11 or 1, depending on these cases. Here's the following list. Have equal probability of being drawn. Beautiful. Okay, okay. So, so if we solve the game, the first thing we do, which is click run. Not this one, actually. It's another demo. Example number 1, go to the demo. Okay, go to the demo. Let me just copy the link. And there we go. That's the demo. Let me add it to the group. Python group. Beautiful. Let's click run. Yes. So here we are having this cards, recurrent cards. So we are drawing two cards directly, and we having the current score. So we're gonna have to have another function. It's gonna be definition of player's card, and then we're gonna go and we're going to take two cards from the list. So cards number 1, card number 2, exactly. And then I'm going to draw random cards from the cards list. So card number 1 is equivalent to a random choice, which is random. So we're gonna take this module dot okay. How to do that? I guess I need some syntax help. I'm gonna use AI for that. How to take a random index from the list, and okay, that's it. So we're gonna have the syntax, because I'm human, I forget the syntax. So we're gonna use random.choice. Beautiful. We're gonna use the syntax. I'm gonna go to PyCharm. I'm gonna use the syntax random.choice from the cards, and card number 2 as well. It's equivalent to that. So we have taken two random choices, card number 1 and card number 2. And if we saw the project, we display a list of these two cards. Okay, so let me just add a list to them. So I'm gonna need an empty list. I'm gonna call it player cards, and it's gonna be an empty list. Oh no, it's not gonna be an empty list actually. I'm just gonna use these two variables that I already have. Yes, card number 1, card number 2, exactly. So this is the player cards, and I'm going to return this player's cards. And here before, I'm gonna need to calculate the score as well. This function, or maybe define another function. Okay, so I'm gonna define player score, and I'm gonna take card number 1, card number 2. Okay, interesting. I'm gonna take this list, which is players cards, exactly. I'm gonna rename this to players cards. I'm gonna take it as if. Okay, beautiful. That's beautiful. Okay, I'm gonna need a little column in here. Okay, I'm having an error in here for some reason. Let me just process this real quick. Okay, here we don't need an input, so this one is unnecessary. Beautiful. I'm just gonna go and take this function. Beautiful. Oh, that's beautiful. Why do I have an error in here? some reason I have an error. Interesting. Okay. I cannot use this. Let me ask AI how to do that. Okay, let's go to Google AI. How to use a predefined function to define another one, like using the return and using that to define another function. Here is an example. It looks like you are trying to call function size. Yes. So we have here define cards, similar, blah blah blah. And then we are returning that. Current player cards. Okay. So I define this function, which is player score. Okay. Current player cards. Calculate the score based on the list of cards passed to it. That's stupid. No. Now I want to use this return that has been defined in this function. And use that to define the player score. Understand you want to apply a score function to always calculate the score of the cards. Yes. Player's cards. Okay. Okay, that's interesting. Okay. I see how that's possible. So I'm not gonna use any input in here. That's stupid. So the score is gonna be actually let me think about this a little bit. It's gonna be cards. Okay. I'm gonna take the player's cards. Okay. It's gonna be 0 index plus player's cards, the first index, and then I'm gonna return the score. So that's how the score is gonna be like. Player score, then player's cards. Then I'm gonna have another function for definition of computer score exactly. And then the computer is gonna have a very similar syntax to here. Why not? And it's gonna have a similar list. I'm just gonna rename it. It's gonna be computers cards. And then I'm not gonna return the whole list. I'm just gonna return the first index. That's it. Because I'm not gonna show the second card the computer has. That's gonna be a secret. And then I'm gonna define the computer. Okay, it's not gonna be score, it's gonna be cards. Then I'm gonna define the computer score. And then I'm gonna take exactly, but I'm not gonna use that. I'm gonna use cards, play computers cards. Replace that with computer. And here as well. Computer, beautiful. So right now we have these functions. So this one is player functions, and then we have here computer functions. Beautiful. Then I'm gonna make a dictionary of these functions. So here we're gonna make a dictionary, as simple as that. We're gonna call it player functions. It's gonna be dictionary, beautiful. So the player functions, we have cards. It's gonna be our first key. And I'm gonna have a column, and then I'm gonna take this function that gives us the player cards as a list. So this is exactly a list of players cards. Beautiful. And then I'm gonna have the score, which is the player score. Beautiful. Okay, I'm just gonna delete this. I'm gonna make a space over here like that. I'm gonna make this, delete it. Okay, I have a space over here. Beautiful. Okay, here are the computer functions. We're gonna have the cards, computer cards, sorry. Beautiful. And then we're gonna have a score, which is the computer score. Beautiful. Okay, that's interesting. So here we get our list of cards. It's gonna be, for example, in here it's gonna be these brackets. We're gonna have, for example, 2 and 3. And if we saw this example, we're gonna have a 5 as a score for the player. And then for the computer, it's gonna be something very similar. And then we have built our own dictionaries following that. That's what we're gonna employ in the while loop at the end. So I'm gonna add this function at the very beginning, because it's a case that I have to catch for these player cards. Okay, so let me think about this. So here we are taking 2 or 1, but if the card was maybe 11, then we're gonna need the score, etc. So all of that is gonna be employed in the while loop at the end. So here I am catching the case of the ace card. Okay, it's gonna have 2 distinguishable scores. Okay, what if we have catched the ace card? But the ace card is a little bit like a joker, like it changes its score depending on the final score. Okay, so for example, if the score was like this, then we're gonna need the score and the card. Okay, and the card in this example, it might be so we're gonna need a for loop for this list. Okay, interesting. We're gonna need to take this one and this one, etc. until we find this ace card, which might be 11. If it was 11, then we might return that or that. Interesting. So we're gonna need to change the score, and that's gonna be a little bit complicated. Okay, so I'm gonna add this functionality later. So I'm just gonna store it in here and develop the game without that functionality, because it's gonna just confuse me. Okay, beautiful. So after we have these functions and these dictionaries, okay. We go to the demo and see your cards, etc. Your current score is 12. That's beautiful. So we're gonna output this in the while loop at the very beginning. So I'm gonna go here to the while loop. I'm going to import the art, and I'm going to print first of all arts.logo. Beautiful, so that we could have the blackjack logo. And then I'm going to access the player cards. So I'm going to access this function, the output of it, which means I'm going to go here to this dictionary and then call it. So I'm going to just print. Okay, I'm gonna need a string, an F string. I'm just gonna take this, your cards. Beautiful. I'm gonna paste it in here. Okay, and then I'm gonna have a comma in here. Then your current score. Beautiful. I'm gonna paste it in here like this. I'm gonna need the curly brackets in here. And another curly brackets in here. So here we're gonna go and use player functions. Exactly. I'm going to access the first key, which is gonna be the cards. Yes. Okay, beautiful. So the key should be a string. Shouldn't forget that. Cards, beautiful. And it's going to output for us this list that has been chosen randomly. Then here we have the current score, which we're gonna go to the player functions. Then I'm gonna take the score and output it. So let's see how that's functioning. Okay. Function player cards at current score. Function player score at what just happened? Why do we have this? What? Okay, that's interesting. So we took a random choice from this list. That's true. And we have made this list, which is player's card, and we have returned it as a value. Okay, the same thing should happen in it. Why do we get this? Interesting. Let's give this to Thony and see what's happening. Let's debug this. Okay, so let's me access Thony. I'm gonna paste this, delete this function because I'm not troubleshooting it. Okay, I'm gonna delete the computer functions as well because we're not gonna need them. Okay, so we are going to troubleshoot this and this as well. Okay, so let's troubleshoot. Okay, so we have this list. I'm going to step out from that. Okay, so we have the cards, which is the player's cards. What? What the fuck is happening? Score function player score at. What? I don't get it. Why? So let me ask AI. That's weird. Why are we not taking the returned values of these functions and we get returned just this? Okay, so I'm gonna go and make a string in here, paste that, then go to here and take this, beautiful, then paste it in here. Okay, let's see what's the problem. That's an exclamation that points to subtle but very important issue with how you are calculating the score in your player score function. You are correct to notice that in the last part of your code, the problem is in here. You are calling player's card twice, once to get the first cards, player cards, and once to get the second card. The problem inconsistent result because the player's cards uses random choice. Every time it's called, you are getting two different sets of cards, not the two cards for a single hand. The first card, oh, okay. That's the problem, that's the problem. Are completing new random pairs. Oh, okay. Okay, so your final score is the sum of two random cards from two separate draws. Okay, that's problematic. Solution: sort the return value first. So, okay. Correct hand, place cards. Okay, so we should sort first. Okay, that's stupid. Okay, we're just gonna fix that real quick. Okay. Current draw is going to be equivalent to player's cards, exactly. Then we're gonna use this current draw that has been stored. 1 second, copy, paste, paste, beautiful. And we're not gonna need these parentheses anymore. Beautiful. Okay, so the error has been fixed. Why don't take the return values to the dictionary definition in this part? You're not calling the function here, you are storing a reference in the dictionary. Okay, the value associated with the key calls in the function name players are stored in the recipe or the tool, not the results of the running tool. You only execute the function and get the return values when you later access them, like this. The cards list, to get the list of the cards. In summary, okay, that's wrong. Like, we have learned that we could do that with dictionaries. If you access day 10, went to here, you could see this dictionary. Okay, maybe we could add. That's weird. That's very weird. Like, you could use dictionary to store the return value. Look. Yes, you're absolutely correct. Storing functions, references, and dictionaries is very powerful and common patch in Python, often called a dispatch table or function map. Okay, how to use the start functions. Okay, add function, blah blah. Connection back to your original question. In your original question, you want to use the return value of player cards to define your play score. Interesting, you are not doing the exact same thing as in your math operated example, storing the function reference. You're not executing player or player score yet. If you want to If wanted the score to be calculated based on a new set of cards every time you look it up, your structure was correct for that purpose. Let's put in function name and dictionary stores the function itself. You must add and arguments you want to execute the function and get its return value. Okay, that's interesting. Okay, so we go to day 11, go to the main, and see what's gonna happen. Okay, so for some reason this doesn't work. Interesting. So I'm gonna take a break, troubleshoot this. I cannot use dictionaries to store my functions, which I should. Let's put on this for the last time. Yes, I want to continue. So this is what's getting printed. That's sad. That's weird as well. Main. Okay. Okay. Okay, that's interesting. Because we need an active input. Okay, that's why. That was stupid for me. Okay, let me just make these functions more into an input. Okay. Okay, beautiful. Okay, so let me just add card 1, card 2, and cards. Okay, so card 1, blah, 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 etc. Interesting. It's kind of complicated. Oh my god. I'm just gonna take a break, refresh my brain, then I'm gonna troubleshoot this, okay? Yeah. Okay, we're back. We're back. So let's do this. So I'm not gonna need these inputs because we're just gonna need one input, which is this list. And there we go. Here we need the current draw so that we calculate the score. Beautiful. And when we are passing these cards, this should be fixed, right? No, still it didn't fix. Okay. Okay, so I'm just gonna pass to it the look at that, the inputs. So I'm gonna need parentheses, and I'm gonna pass to it the cards, just like that. It should function, right? Let's see. Yeah, let's go. This works. That's beautiful. Okay, current score. So for current score, I'm not getting a return from the current score. What about doing this? Normal parentheses. Let's see if that functions. Nope. Score, current score, blah blah. Place card missing record position argument, which is cards. Okay, let's do that. Okay. Okay, that's weird. Okay. Okay, beautiful. First call sticking the argument was one given. It's problematic. It's actually calculating this score. Yeah. I'm not gonna troubleshoot this, I'm just gonna troubleshoot this for the moment. Okay, so I'm taking the current draw from this function. It's interesting. I just have an idea. Why not just take one function and let it do all of those things? For the moment, it's gonna be enough. Players' cards and score. Okay. And for this case, I'm gonna calculate the score as well. This is gonna be way simpler for me. Okay. Beautiful. So this is the score, and we are going to return the score as well. So we're gonna make an F string. Okay, and for this F string, I'm gonna go and output players cards, and so your cards, player functions cards, etc. And I'm gonna add this current score as well into here. And at this place, I'm gonna add the score directly. So this function is just a waste of code. It's not that important. And here I'm gonna use the player's cards as well as here. Player's cards, beautiful. And I'm gonna need only one function, so I'm not gonna need to make a dictionary. It's gonna be a waste of code. It's only one function. It's gonna be enough to calculate everything. So I was just experimenting with Python, seeing what I could do with it. Okay, in here, I'm just gonna go and grab this. I'm gonna grab this score as well, but from this list. Beautiful. And I'm going to return this as a whole. Okay, I'm going to replace this with this list, and the score is gonna stay the same. Okay, beautiful. So in this case, I'm not gonna show the computer score. Okay. And I'm not wanting to show all the computer's cards, so I'm just gonna go and show the computer cards. The first one, which is gonna be first index. I'm not gonna show the second one. I'm not gonna show the score. Okay. Beautiful. This is the only thing I'm going to show for the computer. As for the demo, so you see here my cards and my current score and the computer's first card. That's the only thing that we are going to show in our code. Okay, so we're going to go here and add that computer's first card. I'm not going to need this function anymore. I'm going to keep it simple and easy to track. Okay, I'm gonna use this function, and okay, I'm gonna delete all of this, use this function, pass to it the list, which is the cards, and I'm gonna use this function. So the input in here is gonna be cards as well. Beautiful. Beautiful, so I'm gonna add it over here. And just delete all of this right away, and pass to it the cards as well, and see. Yes, so I have 10, which is my mean. I have 20 as score, and the current score. Okay, I'm not gonna need this for the moment, so I'm just gonna go and see the. Okay. So here I'm gonna need a new line. Beautiful. I'm just gonna make a new line. Just like this, and see how it's gonna run. Okay, beautiful. So this is actually functioning. Beautiful. Okay, so I'm gonna go and I'm gonna see, I'm gonna make an if statement before this, which is gonna be if statement if player's cards score. Okay, hold on a second, what's happening here? So I'm going to store this as okay, interesting. We're gonna go like this, and I'm gonna store this as I'm gonna store this locally, so players list. Okay, and I'm gonna store as well the score. So player score as well, and player list as well, and I'm gonna take that from here. The same thing is gonna go for computers list and computers score. Okay, that's interesting, but here in this we are not actually outputting the score, which is problematic. Well, that's problematic, isn't it? That's gonna be very problematic for the long run. Okay. Okay, because we cannot actually output much of the computer, so this return statement. Okay. I have a question to the AI. Could a function have multiple outputs? Because in my script I want a certain outputs and another one from the same function. Okay, beautiful. Is that possible? It's a function in Python can have multiple outputs by returning a single object. Okay. My problem is that I cannot return both of them. This is problematic. What's the solution for this? Okay. Because if I have returned it like this, it's gonna be cheating for the player. So what's the solution? What is the solution? I'm gonna need some cases for this, right? I don't know. I don't freaking know this. Okay. Maybe I could get rid of this as a whole, and I'm gonna be a little bit strict for this, so I'm gonna need computer scars list first. This is the first thing I'm going to grab, and I'm going to grab as well the score. Okay, and I'm going to grab computers cards, so I'm going to grab the first card. Beautiful. Okay, so I'm gonna grab the list, the score, and the computer's cards, and in here so I'm gonna add first our I call this card 1. Okay, in here I'm going to output the card 1. Okay, so let's see if this actually functions. Nope, doesn't. Too many values to unpack, unexpected. Okay, let's see if this is possible. I have returned from a function 3 values. Okay, beautiful. And I want to assign each value to its own variable, and it's gonna be this one, like this. Let's see if that's possible. You are on the right track to assign 3 returned values to 3 separate values. Use tuple unpacking right where you call the function. If your function returns 3 values, you need to provide exactly 3 variable names on the left side of the assignment. Okay, you would assign them like this. So I'm returning this, and I'm assigning it like this. Okay, so this should work, but I am having for this instance an error, which is this, which is weird. Like, why do I get a error? Then why I have this error. Okay. Come on, man. That's not what I have meant. Why didn't I copy? Go to here. Copy. And I'm gonna paste it. And I'm gonna run this again. Let's see. Okay, the value or too many values to unpack is a classic Python error that tells you exactly what the problem is. We're expecting you have two variables on the left side of the assignments. The function actually returns too many values. The function player's code is returning more than two values. To fix this, you need to check the definition of the player's code score function and ensure it returns exactly two items, or you need to provide three variables names on the left side. Okay, and that's exactly what I have done. What the fuck? I don't get it. That's weird. Okay, I'm gonna rename this first card. It's gonna be here as well. Let's see. Okay. Okay, no problem. Not a single problem. Here, I did it. That's weird. Okay, here we've currently identified the source of the error. In previous attempts, you fixed the assignment for the computer's card. What's happening here? This means is returning three values, but you have provided two variables to receive them. Okay. Now that's weird. Okay. To fix this, add a third variable. I added a third variable, and for some reason that's not being processed. What? I don't get it. I don't get it. Is Python stupid or what? PLSP score. PLSP score. Oh, we're talking about this one. Oh, okay. Because I'm using F string, that's why. Okay. Okay, no problem. I'm just gonna delete the whole F string because it's a string. It's not anymore. Okay, I get you. I'm gonna use the player's cards and the score, and that should work. Let's see. Yes, perfect. So your cards is blah blah blah. So we have a list and we have the score. Then we have the computer's score. Perfect. Uh-huh. I'll call this computer first card. Okay, computer first card, exactly. And in here we are actually going to output F string, and I'm not going to use this function anymore. I'm going to use this beautiful. I go to the demo and get inspired from it. So your cards is this and your current score is this. Beautiful. So my cards are these. My current score is this. Okay, then we have a new line for computer's cards. Computer's first card. Okay, let me just copy this. Beautiful. Okay. And we are going to type that here. Okay, so here we're gonna use player list. I'm gonna use the current score, which is player score. Beautiful. And here we have the computer first card. Okay, so this should function. Yes, exactly. It functions like butter. And then we have these beautiful functions calculating for us the score and everything, which is beautiful. Okay, I'm gonna call it computer cards in score as well. And I'm going to rename it in here. Yeah, beautiful. Okay, so after this, we're gonna have to give me a second. We're gonna need to add some functionalities. And do you wish to continue? Okay, it's gonna be more of another while loop. While true. Okay, and then I'm gonna add cards. Okay, and I'm gonna make an input. Do you want? So I'm gonna go to the demo. Type Y to get another card. Type no to pass. Exactly. Okay, just paste that in here. Like this. Okay, so if add card is no, then we're going to break this. Yeah, break. Beautiful. Okay. So in the case of, hold on a second. So this if statement should be the first thing of this code. Okay, beautiful. Okay, so if the case is yes, which is else, it's going to be an else statement in here. Then we are going to execute our code. It's going to be, we're going to add a card to our player list, and let's do it. So we are going to choose player list, p list, exactly. Come on, man. P list, I'm going to append, and I'm going to choose a card from a random card, which is random.choice from cards. Okay. And for this sequence, could you actually okay, that's interesting. Okay, so we have some problems with this. We need to edit our functions so that they become infinite. Maybe they have this while in here. It's gonna be better if we add this while, isn't it? Right? And it's gonna be better if we made a whole function for the computer and the player. The same thing, right? I don't know. It's kind of difficult, isn't it? Let me think about this. So what we are doing is add a card. Okay. But this would make these functions irrelevant. They're going to be useful only for the first time. And just like that, we're gonna have a bunch of non-optimal code, okay? And I don't want that. So I'll have to edit this function and add to it this while loop so it could be more flexible, okay? And for that reason, we're gonna need to okay, let's add the while loop first, and then we're gonna worry about the computer score as well and cards. Okay. Okay, beautiful. So we're gonna give the player these set of cards in this list as the beginning. Then we are going to add a while loop in here. Okay. If the player wishes to add a card, then we are going to append this list. Player cards with append a random choice. Interesting. But for that reason, the player should see his cards, and so he should see his score and everything else. For that reason, there's a better way to implement this. Yes, there is a way better way to do this, so I'm going to delete this for the moment. I'm going to copy this and I'm going to delete it. I'm going to delete all of this. Okay, I'm going to delete all of this as well. And we are going to add this over here. Okay, beautiful. And we are going to ask about this for later. So it's gonna be here. Not all. Oh my god, what happened? What happened? AI is freaking with me. Okay, beautiful. So, the first thing we are going to do is okay, let's focus. We're going to give the player a set of cards for the beginning. So card 1 and card 2. But before that, we're gonna need an empty list, which is player cards. Beautiful. It's gonna be an empty list. And we are going to use hold on a second, let me think of this. Okay, beautiful. So the first thing is gonna be as a set of beginning cards. Okay, let's add that. So we're gonna have card 1 equals a random choice from the cards. In card 2, the same thing. And I should append that to the list. So p.cards.append, yeah. And I'm going to append card 1. Could I do this? Nah, I can't. Okay. It was worth it. Okay, beautiful. So I'm gonna append these to the P cards. So I'm gonna just check P card that appends card 1 and card 2. I can't do that. Ask AI because I have a warning. Okay. Can I append 2 cards in a list using the append method? No, you cannot use append method to add 2 items. Okay. Not extend. Or we could use it 2 times. Okay, so we could use this dot extend. Okay, beautiful. Okay, interesting. That's very interesting. So my goal is to make this let me think of this. I have an idea. Either we make infinite loop. It's not gonna be that optional. It's gonna be way simpler than what I'm trying to do. I'm just trying to make things complicated, which is good, but it's not optimal for my case. So I'm just gonna make 2 simple functions for the beginning. So I'm gonna delete this while loop as a whole. Beautiful. So I'm gonna keep these 2 functions like this, and I'm gonna add my code in here. Okay. Yeah. Okay. So else we're gonna add a card, random card. Then we are going to calculate the score, which is the player score. Hold on a second. Player score. Player score is not. So the player score is gonna be the sum of this list of player list. Yes. Okay. Then we have a new score, and let's say if the player score was above 21. I said player score in here, right? I'm getting mad because of this. Player score, yeah. And if that was above 21, I'm gonna print to the player your cards exceed the limit. I'm gonna add an F string in here, and I'm going to output his score, and I'm gonna type you lose. Beautiful. Otherwise I'm gonna add, and I'm going to break, yeah. I'm going to break this while loop as a whole. We're going to break, then we're going to add to this while loop, which means you want to repeat or not. Okay, This is the structure of my code. It's not optimal. I don't like it. I hate it because I've made these functions and I want them to be so much more flexible. But it's gonna be way harder for me for my level of coding. So I'm just gonna keep it simple, keep it like a story. So yeah, it's not gonna be optimal. So I hate it. It's alright. Okay. So I'm going to check about the score. If it was above 21. If it wasn't, else, then we are okay. Okay, so adding a card. If I say yes, I'm just gonna take a break. So I like to take a break, so come refreshed and think about this. So yeah, that's what I'm gonna do. We're back. Yay. Okay. Let's do this. Seems that I am suffering doing this, but we're gonna do it. Okay, let's go. Believe in myself. Yeah. So before we break, in this case, I'm gonna go and say I'm going to compare my score to the computer's score and say if player score, hold on a second, if player score is actually equivalent to 21 and computer score, yes, was equivalent to 21, then in this case we're going to print it's a draw. Your okay, your score is, hold on, need this, your score is, then I'm gonna spawn up the player score. Okay, and the computer score is computer score, beautiful. And we're going to break from this while loop. Beautiful. Okay, if that happens. Otherwise, I laugh if the player score, come on man, if the player score was okay, was actually below or equivalent to 21 and actually bigger than computer score, yes, computer score, I'm gonna delete this, yeah. So what's happening here? There's some kind of error in it. Yeah, okay, that has been solved. So if the player score was below or equivalent 21 and bigger than the computer score, then this means a win for us. Okay, we're going to print, okay, I'm gonna need this, you win, you win. Okay, I'm gonna need an F string, and I'm going to print the player score compared to the computer score, which is that. Okay, beautiful. If the computer score was actually below equivalent to 21 and bigger than the player score exactly, then this means we have lost. Print if computer when compared to the score compared to your to your score. Simple as that. Going to edit that as well. Your score is blah blah blah. Okay, beautiful. So these are the cases, I guess, should be functioning for the moment. Okay. Okay, hold on a second. Have the score, blah blah blah. So we're gonna delete this break statement. We are going to indent this as this one as well. And we are going to add this case as well in here. Okay. Hold on a second. So we're adding a card and we're saying no, I don't want to add this card. Okay, beautiful. In that case, we are going to check this and this and this. Beautiful. Or maybe rather than repeating the code, I could just copy all of this, all of these if statements, and delete them. And I could use them in here. Boom. Delete all of these indentation. Beautiful. Beautiful, beautiful. This is gonna be way better. And delete this one as well. This one, beautiful. I'm gonna add this one for sure. So to just keep it more optimal, I have this idea. Here's gonna be an LF. Beautiful. Okay, good. Okay, here we're gonna have our logic, our process. Here, the whole value of this is to check if we want to continue or not. If not, then we are going to break. As simple as that. So just to keep the code simple and optimal. Beautiful. Like this, I could actually have a more optimal code. Beautiful. I'm going to delete this break here. Let's delete this else statement over here. Beautiful. That's great. Okay. So if we didn't add a card, we're going to break it and we're going to make this logic. Otherwise, if we didn't want to break from this, we are going to add a random card to the list, and we are going to make a new score of the player. Okay, and say if in the computer would make, for example, if his score, I'm just gonna make the computer a little bit smarter. If the computer score was actually between, I'm gonna have this I'm gonna have this. So هذا هو l'encadrement ديال of computer score. Okay, beautiful. So if it was between 18 and 21, we are not going to add anything to, we're just going to pass or continue. Okay, yeah, I'm just going to continue. Beautiful. So if the computer score was between 18 and 21, we're not gonna add a random choice. We're not gonna add a card to the computer list. Okay, otherwise, else, then we are going to add to the computer list, we are going to add a random choice, and then we are going to calculate the score again using the sum function. Okay, beautiful. So this is the while loop that we are going to do. It's just to update the player score and the list, and the computer score and the list. Okay, and the player is gonna have his data and he's gonna make a choice. But for the computer, he's not that smart, so we're gonna add this case for him to help him. If your score was pretty high and close to 21, you're actually not gonna add a card. You're gonna be smart, okay? Otherwise, if your score was below 18, then you're gonna add a random card and you're gonna sum it. Okay, beautiful, beautiful. And then we're gonna have this logic if player score was like this, and we're gonna have another rule, lf, computer score, yes, was above 21, then print. Okay, we're just gonna print computer costs exceed the limits, UN. Okay, beautiful. So we're just gonna make some spaces so that the code is more readable for me. Okay, let me go through this again. So we have defined these functions, which does seem a little bit repetitive, but I guess they function. And we have assigned from these functions the output to each variable inside this while loop: player list and player score, player card and score, computer card score and computer card 0 for the player to see. Okay, so the player, first thing he's gonna see is this, his cards and his score and the first card of the computer. And then we are going to ask him, do you want to add another card? If no, we're going to break this while loop. Otherwise, we are going to append a random choice to his list. We're going to recalculate the score, and we're going to add a rule for the computer, the poor computer that doesn't understand anything. We're gonna say if your score was below 18, then you could actually add what you call this, you could actually add a card to your list. If it was between 18 and 21, then okay, I could add here R. Okay, let me see. Or if it was your computer score, if the computer score was actually exceeding 21. Okay, let's see, we have an error in here. Beautiful. Okay, so if the computer score was actually a bust and it was above 21, just continue because you have already lost. Okay, otherwise you could add to your random choice a card. Okay, So that's it. So right now the computer is smart, and for the player we are giving him a choice each time for this while loop, and we are having this while loop. Okay, let me just delete all of these lines like this. We are having this while loop to play the game again, and to play the game again we are going to draw new cards, etc., and we are going to activate these functions from the very beginning. So I guess the game has been developed, so let's test it out. Okay, so your cards, so my score is 8, correct, and the computer first card is 10. Okay, I'm going to add a card, so I'm gonna type Y. Okay, I have a problem in this while loop in here. So if it was yes, we are going to add this, and we are going to print your cards and your score. Beautiful, that's true. Yes, that's exactly what I'm trying to print. Player list, the new card that has been added, which is from here, and the new score. Okay, so I guess with this the game has been finished. Okay, so my score here was 15, true, and the computer had 11. Okay, type Y to get another card, type no to pass your cards. So now we have added 6. Okay, that's correct. So it's 21. So I'm not gonna pass. I'm gonna type no. Computer's cards exceed the limits. 31. You win. Okay. I said for the computer to not add anything, right? To just continue. To not add anything. Okay. Let's see. Let me ask the AI if this is true or not, because the computer is 31 and that's wrong. He shouldn't reach 31, that's too much big. Which means one of my rules is wrong. Maybe it is this or statement. So if this was true, we are going to continue. And or if this was true, we are going to continue. This seems to be correct for me. Why the computer exceeds the let me just try the game again and see what's gonna happen. Maybe because of the ace card. Maybe because his first card was 11 and he had another card. No, I don't know. I don't think that was the case. He shouldn't take another card, which is weird. Why the computer exceeds the limits. Why the computer does not follow this case rule. Okay, let's see. Computer logic, the part that handles C code is not executing at all in this section of code you provide because it's trapped inside a condition that prevents it from running correctly. Let's see. So else p doesn't append, blah blah blah, print around. So if it was like this or like this, then continue. Else, make that. The reason the computer isn't following the rule, the computer only takes another card if its current score meets specific conditions. The computer will not draw a card if the score is between 19 and 20 because the condition. Okay. I'm gonna need to add an equivalent to it. Yeah. I need to add equivalent like this. Hold on a second. Yes. The continue keyword image just gives the rest of the current loop iteration. It does not mean iteration while true loop. Okay, therefore the computer is not following a rule because it's currently in a state where it should stop drawing based on the condition you are at. What your code implies the computer should do blackjack logic. The logic looks like an attempt to implement strategy. If the computer has a strong hand or has already busted, do nothing and move to the next continue. Okay. So my rules seems to be working just fine. What the fuck did I do? Okay, let's get back to PyCharm and go and select this rule. I'm gonna type, is this syntax correct? Let's see. Python syntax you wrote is syntactically correct in Python. So yeah, the condition also covers the range from 18 up to 21. Okay, so through this condition he should work just fine. Okay, so the computer has 11 and I have 12. I'm gonna add another card. Okay, so my score is 14. Okay, there is another rule. If let me just write it down like this. If the score was below 17, then you should then you can't break this while loop. Okay, so in here, if add card and the score, which is player score, was actually above 17, so it's gonna be like above 17 like this. Beautiful. Then break, then you have the right to break. So type Y to get another card, type no to pass. If your score I'm gonna add an if string in here. I'm gonna input here the score, the player score. Yes. If your score was bigger than 17. Okay, let's see this again. Okay, beautiful. So your cards is 20. Computer's first card is 7. So I'm going to pass. You win. 20 compared to the computer is 13. Okay. That was lucky. Do you want to continue? Yes. Okay. Computer first card is 9. Do you want to continue? No. You win. Okay. Okay, so my current score is 6. The computer as well is 6. I want to continue because I should have at least 17 in score. So it costs 335, which is 11. Still, I want to continue. Your card's current score is 17. Okay, so I could pass. What happened? I just passed, right? So my score should be 17 or equals. Okay, like this. Beautiful. Let's see. My score is 16. Okay, and I'm gonna make another card. So my score is 20. So I have a lot of luck. I'm going to skip. Okay. So if I skipped, which means I breaked from this. What happened in here? I have 20 in here. The computer should have a set of numbers as well. Okay. Maybe we have a problem with this logic. Maybe. Why didn't we have anything? So if we didn't have anything, I'm just gonna go and troubleshoot this code and see. I'm going to print everything. Print. I'm gonna print an F string. It's gonna be computer score. Player score. Beautiful. And player computer score, player score. And computers score. And cards. For the cards, we're gonna have computer cards. Okay. Computer score, computer list actually. This, beautiful. And here the player score and player cards. Then I'm gonna give this player list, beautiful. Let's rerun this. Okay, your cards, 10, 10 is 20, computers first card 16. I'm gonna pass with no. Okay, your win compared to the computer is 16. Computer score 16. Cards, yes, you play a score, okay. So I win in this case. Yes, I want to replay. So my score right now is 21. Computer is 8. Okay, so I'm gonna pass. Okay, you win compared to the computer score is 18. Computer score 18. Okay, player score, so I win in this case, that's true. Let's replay again. The score is 20, the player, okay, I'm gonna pass. Okay, computer score is 21. Okay, so in this case, computer win. Okay, that's true. 20, computer score is 21. Hold on a second. How much my score? My score is 20. Computer wins. Okay, here computer wins. Computer score is I should here give the computer score and here the player score. Okay, so this issue has been fixed. So the game actually, the first version of it, it works. I still have to add this ace card depending on the case and this while loop, or here, I don't know. So it's gonna be a little bit difficult to integrate this functionality in this code. I'm gonna take a break for that, but who knows. Okay, so here we have 17, computer's first card is 10. Okay, I can just pass. You computer win compared to your score, which is 17. Okay. Okay, beautiful. So this functions. Let's run this again. Type Y. So my score is 15, so I'm going to take another card. Right now it's 17. I'm going to pass. Computer wins 19. Okay. Okay, so this works as it's supposed to be. Beautiful. So there is no issues, not at all. And I could comment out this for the moment. Let me just comment out. Yeah. And the game has been done with the experts niveau. I just missed one thing, which is the ace card. I have to integrate it, which is a very important rule. The ace can count as 11 or 1. And if we solve the course, if your cards were below 17, it's going to be 1. Else, then it's going to be 11, okay? Or maybe you choose, let me ask AI about that, to just make sure. If why does the ace card take 2 values? 1 or 11. In which cases does that happen? Let's see. That's a fantastic question that gets to the heart of the game blackjack. Your card logic seems to be inspired. Okay, the rule of the ace. The ace counts as 11 unless counting it as 11 would cause the player's total hand score. In that case, it counts. Oh, okay. Does it count as 1 or 11? And some common scenarios, assuming the ace is only card counting as 11 initially. Okay. Okay, interesting. Why 16 is below 21, so it stays. Oh, so if the score, okay, let's get back in here. So I understand. If the score was so let's say ace is 11. If the score was not exceeding 21. Okay, if the score is exceeding 21 with the ace of value 11, then it becomes 1. Okay, let me say to the AI if this was true or false. Is this logic true? Yes, that is the core logic for handling the ace in blackjack. Okay, simplify statement capture the decision process perfectly. Check ace is 11 with the score assuming. Okay, beautiful. So with this knowledge, I'm not gonna need this function. I could just use this logic and this place, okay? And the result, when I'm taking the result, the scores. When I'm comparing the scores, I could maybe manipulate the list, the player list or the computer list to set the right ace value, okay? So this is, the last feature. I'm gonna take a little break. When I come back, add this feature and then continue the course with the next project, okay? So this is a very stupid project, very easy. And yeah, you don't need a chart for this. You could actually just take the demo and try to mimic the demo followed in this, could mimic the logic followed in this demo, okay? Beautiful. Okay, let's continue. Hooray, we're back. Let's get it. Okay, so the first thing we're gonna do is update our script so that we have a functionable ace card. So ace is 11 if the score was not exceeding 21. So after we have got the scores that we need in everything, first of the things, we are gonna make an if statement, and if the score is not exceeding 21, so if player score was actually below 21, okay, so it doesn't exceed that, it's gonna be the value of 11. Okay, so it's gonna be the normal value. So for this case, we are not gonna care about that. Okay, so the score was exceeding 21. If the score was bigger than 21, maybe we're gonna have this if statements. Maybe over here, so the very first beginning. Okay, the very first thing we're gonna ask about is this if statement, and we're going to make sure of this if player score, and we're gonna make sure if this player score was for example, let me think about this, it was exceeding 21, the ace is gonna be transferred from 11, where is the, yes, so this card rather than being 11 is gonna be 1. Okay, and to do this we're gonna need to spot this, so we're gonna use a for loop, and to spot if we had 11, so for number or for cards, and cards, okay, I'm gonna check if we have or maybe wait, no, if in player cards, actually player list, so it's gonna be player list. Beautiful. Okay, so for each card in player list, we are gonna go and check if this card is, so if the card is equivalent to 11, then the card is going to be equivalent to 1. Okay, simple as that. Okay, so that's it. I'm gonna call this a C, I'm gonna call this a C, and then I'm gonna call this a C. Beautiful, for a card. What do we have here in warning for? C definable without usage. I don't care. Okay, so for this case, I'm gonna go and print the score. I'm gonna print the lists, player list. So I'm just gonna print that. Print player list. Hold on a second. Simple as that. And I'm gonna go and run this and see what's gonna happen. Okay, so this is the player list. It's 10 and 10, and my current score is 20, so I'm just gonna skip that and I win. Beautiful, because the computer is 18. Next, your cards 3-7, my current score is 10. Okay, I'm gonna skip that. So my score is 10, so I'm gonna take another card. The current score is 14, I'm gonna take another card. Current score is 17, so I'm just gonna go and say no. And computer wins because he has a 20. Okay, interesting. Interesting computer. Okay, do you wish to continue? Yes. Okay, so here we have an 11. Okay, and my current score doesn't exceed 21. But if I exceeded this score, okay, we're gonna have 11, so that didn't change. What happened in here? Why is the ace didn't change to 1? That should make her change. Maybe I have to update this list. This for loop. So if we catch the car and let me just rename it to card because it's more obvious than C to read. Okay, beautiful. So first of all, I'm going to see the index of the cards and the player list. So I'm going to go player list. Okay. I'm going to do these brackets, take this card. Okay, so this is the index of it. I'm going to call this index over here. And I'm going to switch this card to number 1. And after that, I'm going to add... I'm gonna go to the player list. So player list again. I'm gonna access the index. Yes. Yes. Hold on a second. I think this is all wrong. That shouldn't be like this. Oh my god. So let's see what's gonna happen. So maybe this one is 11. It is in there. So the index is gonna be so this is not the index of it. Okay, so this one is a wrong syntax, so I need to farm this index that I don't have. How to get the index of a value in a list. I have maybe 1 and I have it stored as a variable and I want to know its index. Let's see, you can dot index. So we could use this method. Dot value. Okay, so this is the index, so we're gonna go to the code. Okay, so I'm gonna take the index, so I'm going to say this is the index equivalent to plist.index. Okay, beautiful. Yeah, and I'm gonna go and update the plist. So I'm gonna go here, plist, and I'm gonna go and type the index that we have farmed. Yes, like this. So this should function. Let's see. Okay, I'm gonna just relaunch this and see if we have an ace, because we need to have an ace to test this out. Still no ace for us. Please an ace. Please an ace. Still no luck. No ace. Still no ace. We are not that lucky. Come on. What is this luck? Come on. Said come on. Give me the ace. Give me the ace. Give me the ace. I am having zero luck in this game. Okay, finally. Okay, So I'm gonna exceed the 21 score. Okay, still we are at 20. Let's exceed that. Beautiful. So it switches to 1. So my code functions. Hallelujah. And because we are above 21, we are going to lose. Records exceed the limits. 28 to lose. Okay. So we have done it the expert way. Only use one hint to complete the project. And the hint was actually the demo. And that was all extra hand. So here we have tons of hints that we didn't use. And this is actually way better than the demo, because if we access the demo, we're gonna just rerun this to see if we have okay, we don't have an ace in here. Oh, what's happening here? Oh, what's happening? Okay, finally, so we are running the demo from the beginning. We have 7 and 3 again. Okay, let's run this again. I don't know, this demo is broken, but who cares? So this is the script. It's beautiful. It's doing its job. And here we have our 2 functions, okay, that we draw from the first very 2 cards, and we calculate the very first score, and we go to this while loop. We get the cards and score from these functions, and then we are asking the user if he wants to draw more cards or not, and we have a logic for the computer, okay, if he has a good hand or if he has a bust, then there is no need to take more cards, which makes this script perfect for this project, very small project. And yeah, that's it. So I guess I could just skip all of this and go to the very final video, which is the solution, and see and compare our solutions together. Okay, there is a lot of code that is not mine. So she is using empty lists and using this minus thing, which is weird. Is game over equals false? Okay, that's interesting. Okay, so for whatever in range 2 underscore, this is an underscore. User underscore cards that appends deal card. She has very interesting code. So we are appending from this function, which is deal card. Okay, interesting. For me, I have used this. I could use another function called deal card, but I think these functions do repeat the same thing. Okay, which is these 2 lines of codes. It is not optimal. And for this case, I would like to, I don't know, maybe use another function to deal the cards. Like this, maybe. Define deal cards. Then we are taking this list as input. Yeah. Then we could just do the same code in here. We're gonna have card 1 and card 2. But that's not necessary because I have written this code like this. So yeah, interesting. This is very interesting. She's using a while loop while not game is game over.
So she is updating this condition over here. Okay, so she calculates the score. She has another function to calculate the score. She has way better implementation of functions than me. So she has these two custom functions, calculate score and deal card. It's pretty interesting. She's doing that for this range, which is 2. I'm kind of inspired from this code. I'm really inspired. So let me just define this deal card. Deal card. It's gonna be empty. It doesn't shouldn't take anything. I need a column, and she's gonna go and return a random choice from this list, which is cards. Beautiful. Okay, that's beautiful. And then I'm gonna go and choose a range. So for underscore in range of 2, I'm going to append to this maybe player cards right over here. I'm going to append to this deal cards. Okay. So before that, I'm just gonna need to make an empty list over here. What do we have here in error? Okay. Interesting. So we could do this inside of the... Okay, so I'm gonna delete all of this if I'm wanting to implement her code. That's not gonna be that good for me. But let's get inspired more, because her implementation of functions is way better than mine. Is it necessary for the long run? If you had a bigger code, yes, absolutely. And my way of implementation is not that optimal. So yeah, that has been noted. So here are the functions. Okay, so here is the deals card. So we are using this. Okay, interesting. We are returning this card. Beautiful. Beautiful. We could actually return this as a whole rather than assign it to this variable. It's going to be just more code, unnecessary. Then here are defining the calculate score. Are using this sum to sum the cards. If it was equivalent to 21, or the length and the length of the cards was 2, then we're going to return 0. Interesting implementation of code, actually. Maybe I should build the script from the beginning with her code, with her hints, actually. Maybe, rather than skipping these hints, because I've just built this, but it's not as optimal. It's repetitive. You know, these functions are not optimal for me. And we are doing pretty much the same thing over here. We are calculating the score, and no, it's not as optimal. Yeah. For this one, I think we're gonna have the similar codes in this part, because every human being would will process the same in the same manner. So yeah. What should I do? Go to the next project or learn her code? I think I should learn her code. So apply Java program requirements and game rules. So I'm gonna go here and learn her code. So this is my project. It's working just fine, but I'm willing to do it all over again. So I'm just gonna delete all of this comments over here.
And I'm going to comment out all of this in here as well. All of this. Beautiful. And then we should make the codes from the very beginning using her implementation of syntax, etc. So she has used this function, so we're going to define it again. Deal cards. On the cards actually. Beautiful. It's going to do something like this. So I'm going to define the list first. Then we're out of returning that exactly. Return the random choice. Perfect. We would import the random choice here. Beautiful. And then we are going to define another function, which is calculate score, I guess, etc. But I just feel sleepy. Do feel really sleepy. Maybe I'm just gonna cut the stream, sleep a little bit, and get back to this.